Hi, this is Deepan here from Cheenta Academy. Today, we are going to discuss the solution of one of the problems that come in the Singapore Math Olympiad in the junior section in 2022. This problem is basically uses the concept of the floor value, which is one of the variety of the box function. And it's a really good problem to discuss about the concepts of box function, how does it work. It also uses some concepts of inequality to prove. So we will discuss the use of inequality, the box function and all over the things in this particular video. So let's see how can we solve this particular problem. In this particular problem, we will discuss about box function, and it's really a very beautiful problem to discuss about this concept, and you will get a very good idea how to deal with this particular type of problem. So generally box function is written in this. If we write box function, let's say fx is a box function, then it is written like this, or sometime also like this. It's also known as floor value of x. By the way, there is another name of it, which is greatest integer function. So the question is this. So let's see how we can solve this out. So to solve this particular problem, let's first focus on the expression, the given expression. So the question simply says, or asking, for how many positive integer distinct value of n the expression can take. So let's start with, what if the box function is not there? Only the n upon 4, n upon 7, n upon 14 and n upon 28 is. So let's think about it. If you simplify it, you would get 0, which is very interesting and might be useful in some later time, but let's see. So now we would take help of inequality. So from the box function, let's take two example of box function. 2.7, the value of this is, or the greatest integer contained in it is 2, of course, and same this. So from this we can have a conclusion, which is, let's say x is a number, a positive number, because n is only a positive integer. So let's think about this one. So this one is always going to be greater than x minus 1. If you check with some random values, you can observe that one as well. Let's take x is equal to 3.7. So it will be 3. But x minus 1 would be 2.7, which is of course lesser than 3. So of course it will hold. Another useful inequality can help us here is box of x is less or equal to, the box of x is less or equal to x. For example, 4. If we take 4, it will be 4. The equality, so that means equality holds in case of integers. And if it is not an integer, then let's say 7.6, it will be 7, whereas x is 7.6. So we can understand these two inequalities. Number one is this and another is this, can help us, and actually it will help us. So box of n upon 4 will be definitely less or equal to n upon 4. Whereas if we use this particular inequality on the others, n upon 7 would be greater than n upon 7 minus 1. That means negative box of n upon 7 would be lesser than negative n upon 7 minus. So we can apply this particular result all over on the others and we'll get the similar results. Like negative n upon 14 will be lesser than negative n upon 14 minus 1, and negative n upon 28 would be lesser than. So let's do one thing. Let's first number them, and now let's add all of them. 1 plus 2 plus 3 plus 4. On the left hand side, we would get the given expression actually, and on the right hand side, it will be lesser than. So equality will not hold here because others are not necessarily integers. And so inequality will not hold here. So n upon 4 minus n upon 7 minus 1, n upon 14 minus 1, and 28. So n upon 4 minus n upon 7 minus n upon 14 minus n upon 28. We figured it out before we started solving this inequality. So plus 3 is the remaining thing. So the thing equal to 3. That means let's call it Fn. Fn is less than 3. That means Fn can be 0, 1 or 2 because n is strictly positive, so it cannot be negative. Because n upon 4 is the greatest one, and n upon 7, n upon 14, n upon 28 are the smaller number than n upon 4, so it cannot be negative first. So now what is required, we have just to find among 0, 1 and 2 which values Fn can have. So of course 0 can be have by F1 only. F1 has to be 0 because n upon 4, 1 upon 4, its box function of course 0. Minus 0 minus 0 minus 0 will be 0. So can I imagine can we get any number for which Fn becomes 1? Let's take F4. F4 will be 1 minus 0 minus 0 minus 0. So 1, we get another value. Now for 2, if we check 12, we would get 3 minus 1 minus 0 minus 0. Okay, so we get 3 distinct values. So Fn can have these values. That means these Fn can have 3 distinct values for positive integer values of n. So this is it. This is about the problem. The answer has to be 3. These 3 values. Here is a challenge question for you. The question is, will we get the repetition of a pattern like after this particular values of n, we will get a repeated pattern there. So think about it and let me know in the comment section. So see you in the next video. Hope you enjoyed this.